So we're going to use the sum formula because 105 degrees, it says it's 60 plus 45 in order to find the sine value and the tangent. Okay, exactly, which means we don't use our calculator, but we use our unit circle. So let's find the sine. Oh, I need to put a pen on here. Let's find the sine of 105 degrees. So the sine of 60 plus 45. Now 105 is not on your unit circle, but we can use these two values that are in order to get there. Okay, so we're going to use the formula that says I take the sine of angle A and times it by the cosine of angle B, and then I add that to the product of the cosine of angle A and the sine of angle B. So this is the formula that is the sine of the sum of two angles. Okay, where 60 degrees is going to be my A angle and 45 degrees is going to be my B angle. Okay, so this is a nice trig formula that we can find in almost every textbook, but for fun we're just going to use it here. So sine of 60 times the cosine at 45 degrees plus the cosine at 60 times the sine at 45. Okay, you probably don't have to write this part every time for your teacher, but this part I am sure they would like to see so that they know you're plugging everything into the right formula to see where, if you made a mistake, where that mistake would be. So try to remember to always include that first step in the problems that you're doing. Because now we're just going to substitute. The sine of 60 is root 3 over 2 from your unit circle. The cosine of 45 is root 2 over 2 from your unit circle. The cosine of 60 is 1/2 from the unit circle. And the sine at 45 is root 2 over 2. All of these values come from your unit circle. Okay, which is why we can do this, because we know what these values are. So now we get to do some fractional multiplication. So when we multiply fractions, we do top times top. Radical 3 times radical 2 is radical 6. And bottom times bottom is 4. Then over here, top times top. And bottom times bottom is that. Okay, so because these have the same denominators, we can write down this in the numerator. And sorry, maybe I should have written root 6 plus root 2, but it's the same thing, root 2 plus root 6. So that is the exact value for the sine at 105 degrees. Root 2 plus root 6 over 4. Okay, and so the cosine uses a similar formula, but we've already done one of those. So let's jump over here and do a tangent one. Because tangent is a little bit on the weird side. So we're going to do the tangent of 60 plus 45. So now that formula says we're going to take the tan of A, the first angle, and add it to the tan of the second angle. And then we do 1 minus the product of these two things. This is the formula for the tangent of a sum of two angles. Okay, tan of the first one plus the tan of the second one over 1 minus the product of those two tangents. Okay, so as you might guess, we're going to have probably a fraction over a fraction, so we're going to have lots of practice dealing with fractional fractions and tons of fun like that. So tan of 60, so this is your A angle again, and 45 is your B, plus the tangent at 45, all over 1 minus the tangent of 60 times the tangent at 45. Okay, now the tangent is a ratio of the y-coordinate over the x-coordinate from your unit circle, but I have a nice chart that I'm going to use to just write down the values, and hopefully you do too, because that makes this a lot easier. So the tan of 60 from my chart is radical 3. That's the tangent at 60 degrees. Plus the tangent at 45, which is just 1, over 1 minus root 3 times 1. So in this case, we don't have many fractions, so it's really easy to do this. We do not add these two things together because they are not the same. So we have root 3 plus 1 over 1 minus root 3. Okay, now that's a nice answer, but it has a radical in the denominator, which you know nobody likes. So we're going to talk about how to get rid of that. So on the denominator, we have 1 minus radical 3. So we're going to multiply by its conjugate, which is the exact same numbers with an opposites operation. Okay, so we multiply top and bottom by this special 1, okay, called the conjugate of your denominator. Okay, and what this does is effectively it will end up eliminating all of the radicals in the denominator. So watch as we do this. I'll do it in green just for fun. So we distribute 1 times 1 is 1. 1 times positive root 3 is plus root 3. And then we have this one, which is a negative root 3. And then we have this one, which is a minus regular old 3, when I have radical 3 times radical 3. Okay, so notice that the radicals cancel out, and you just have a denominator of negative 2. Okay, so that is why you multiply by the conjugate. Okay, same numbers, right? We have a 1 and we have a 1, and we have a radical 3 and a radical 3, but the opposite operations, because we want these things to cancel out when you multiply them together to get rid of the radicals. But on top, we still have to do it normal, so there's my distribution up here. And it's okay to have radicals in your numerator. Nobody really cares about those because they're just there. So we have a 4 plus 2 radical 3's in your numerator now. All divided by negative 2. Okay, now there's two ways we can think about this. On top, we know that both of these terms have a 2 in common. Right, a multiplier of 2. This is a 2 times 2, and this is 2 times 1. So I can factor that out there just so that we can further simplify this by canceling those out. So your final answer would be the negative of 2 plus radical 3, or negative 2 minus radical 3 if you are so inclined to do that. Okay, so that's working all the way down to its no longer rationals in the denominator, and like you would see on an SAT or an ACT type multiple choice question. Okay, which is good. We expect the tangent to be negative at 105 degrees, and our answer is actually negative, so that one might make a little bit of sense.